So, good morning, Jai Gurudev. Today we are going to see the remaining part of matter in our surrounding. It will be our part 3 of the topic. We have seen two videos earlier. So, this is our part 3 of the topic. Before going to today's class, let us quickly revise the thing that we have done so far. Let us have a look at the mind map, the things that we have already done. Yes. We have a look at this one. So look at this thing. In the last class, we have seen that what is matter. We have seen that matter is anything that has space and occupies some volume. We have seen that in the last class that matter is anything that has space and matter occupies certain volume. In the last class, we have seen the physical nature of the matter. We have seen that matter is made up of particles, and these particles are very small. And we have seen that how different properties of the particles, that is, matters have space between them. And we have also seen that the matter are continuously moving. And then we have seen that the different parts, or the different molecules of the matter, or the different atoms of the matter attract each other. So we can say that the different matters, the particles of the matters attract each other. So today we are going to basically discuss about the three states of matter, the solid, liquid and gaseous. And as I said to you that there are actually five states of matter. One is another two being plasma and Bose-Einstein state. And since these two does not have any physical existence, so it is not included in your course. And we will also see in the today's class how we can convert them solid into liquid and we can convert liquid into gaseous. We will see the different methods of interconversion between them. So, our first topic, different states of matter. So, we know there are three states of matter that has existence at normal temperature. One is solid, another one is liquid, and the final one is a gaseous. One is solid, one is liquid, and one is gaseous. These are the three states of matter that exist at room temperature actually, or normal temperature, that exist at normal temperature. So before going in details about what is solid, what is liquid and what is gaseous, let us take some example of solid, liquid and gaseous. So this is an example of what? This is an example of solid, liquid or gas. Tell, there is an example of solid, liquid or gas. So this is an example of, solid. There is an example of solid. This is example of what? This is the example of liquid. And you can see this is a balloon, and inside balloon what we have? What we have inside the balloon is filled up. The balloon is filled up with what? Solid, liquid or gas? The balloon is filled up with gases. The balloon is filled up with gases. So see, from these three examples, we can see that there are difference, that the solid, liquid and gases, they are not same. You can see that there is a difference between solid, liquid and gas. These three are not the same. These three are not the same. So first let us see the cases of solid. See, solid have a fixed shape and volume. Solid have a fixed shape and volume. Whatever solid you have, for example, the mobile that is in your hand is an example of solid. And it has a fixed shape and fixed volume. It is a fixed shape and it has a fixed volume. Solid cannot be compressed mass. Solid cannot be compressed mass. See, you cannot compress the solid. You cannot compress the solid. Right? Means you cannot make a solid larger or you cannot make a solid shorter by applying the pressure. It can break, right? But we cannot compress much. And solids are very high and solids are very heavy. Solids are very heavy because they are very high, because they have a very high density. Solids have very high density. And what is density? Density is generally represented by a symbol rho, and and the formula of density is mass per volume. In today's class, we will discuss every point. So don't worry. We will discuss why the density of the solid is high. After some time, we will discuss this one. That why the solid have very high density, right? Then these are the solids do not fill their containers completely. Solids does not flow. These are some other properties of solid. The solid don't flow, right? So by itself. So see, these are the properties of the solid. It has a fixed shape and size. It will not flow by itself. We cannot compress it, or it does not fill the containers, and the solid have a fixed shape. You cannot change its shape. So now come and let us see the things of liquid. What is liquid? Liquid have a fixed volume, but they do not have any fixed shape. Right. Liquid takes the shape of the vessel in which they are kept in. So liquids does not have any fixed volume. Liquid does not have any fixed shape, but it has a fixed volume. What does fixed volume mean? What does fixed volume means? Suppose you take 1 liter of H2O, 1 liter of H2O from you take 1 liter of H2O. Suppose you take 1 liter of H2O from school, and you want to, while coming home, you just want to transfer this water. So for keeping this amount of water in certain container, it should be 1 liter or more. It should be 1 liter or more. That means what? The volume cannot be changed. The volume of 1 liter cannot be changed. The 1 liter will remain 1 liter wherever we take this water. Wherever you take this water. But the shape of the liquid will change from container to container. Whatever container you put the liquid will take the shape of that container. The liquid will take the shape of that container. Okay. Next point you see, like solid, liquid cannot be compressed much. Liquid also you cannot compress much because the volume remains fixed here. Liquids have this density, but we will discuss later in details, that they have a density which are smaller than solid but greater than gaseous. See, they are usually less dense than solid, but their density is greater than gaseous. Okay? And liquids generally, liquids generally flow easily. Liquids generally flow easily. So see, this is the liquid. It is just taking here the shape of a glass because we kept it in a glass. So it is just taking the shape of what? It is just taking the shape of glass. It does not have any fixed shape. Now you kept it in another container, it will just take the shape of that particular container. But volume will same. Whatever measurement is here, suppose here the measurement is 200 ml. So whatever beaker you keep, it will always be 200 ml. It will always be 200 ml. Its volume will not going to change, but the shape will change depending upon the container in which you kept it. Now our third one. Third one is a gaseous. Gaseous. See, gaseous neither has a fixed shape. Gaseous neither has a fixed volume. Gaseous neither has a fixed shape or neither it has a fixed volume, right? So see, when we are moving from solid, then we are coming to liquid, and then we are coming to gaseous. You can see that solid, it has both fixed shape, fixed volume. Fixed shape, fixed volume. Here we are losing the shape. It does not have any perfect shape. Now come to gaseous. Gaseous have nothing. Gaseous does not have a perfect shape, neither the volume is same. This is very interesting. Gaseous, the volume are not fixed. In gaseous, the volume is not fixed. Right. Gaseous take the volume of the container, and here you can see this point you see here. Gaseous fill the container completely. Suppose you have you have this box. Suppose you have this box and amount of gases is present inside this box, and amount of gases is present inside this box. Right. So what the gases will do? The gases will occupy the volume which is equivalent to the volume of that container. Right. Now you take out this gas. Now you transfer these gases into another larger beaker. You transfer these gases into another larger beaker. The same amount of gases will occupy now will occupy now this volume. So if earlier the volume of the gas is 1 liter, now the volume of the gas will not be 1 liter because it will be covering the entire container. This same amount of gases, but they will covering the entire container. Why? We will see in the coming slides. Why? So now the volume will not be 1 liter, the volume will be more, it will be 5 liter or it will be even more, 10 liter. The volume will changes. You can see this is the balloon. So whatever gases the balloon has, the volume is exactly equivalent to its shape. You take out all this and you keep it in another small beaker. All the gases, all the gases can be accommodated in such a small space. So solid, definite shape and definite volume. In case of liquid, it in case of liquid, the thing is that in case of liquid, the thing is does not have a definite. It does not have a definite shape, but it has a definite volume. Here, it has a definite. It does not have a definite shape, neither it does not have a definite volume. Now, thing is that these are the things which we are knowing from our very lower classes. We know them from 6 or 7, I think. That solids are something that has a definite shape, that has a definite volume. Liquid is something that has a definite shape, but it does not have a definite volume. Alright. And gaseous, gaseous neither has a definite shape or neither it has a definite volume. Correct. Solid, once again, solid, definite shape, definite volume. Liquid, liquid, definite volume, no definite shape. Gaseous, no definite shape, no definite volume. Now, why it is? Why? The question is why? Why the things are happening? You see, whether it is solid or liquid or gaseous, they are made up of particles. We said in the previous class that solid that matters are made up of particles, and solid, liquid, gaseous, all they are what? They are the different forms of matter. They are the different forms of matter. So they have particles. And what are particles? You said they are atoms. So see, in solid, the force of attraction between the atoms is maximum. There is a very strong force of attraction between the different molecules. And due to this strong force of attraction between the different molecules in solid, these molecules cannot move freely. These molecules cannot move freely. These molecules cannot move freely. And since these molecules cannot move freely, that's why solid has a definite shape and it has a definite volume. Now come to liquid. In liquid, the intermolecular force of attraction, you can see there is a much more space. The space between the atoms or molecules increases and the force of attraction decreases. The force of attraction is highest in case of solid, then in liquid, and in gases you see the force of attraction is almost negligible. It is almost negligible force of attraction. It has almost negligible forces of attraction, and that is why the liquid does not have a definite volume, and since in gases the force of attraction is very negligible, So it neither has a definite shape nor it has a definite volume. In solid, due to this strong intermolecular force of attraction, it has a definite shape and definite volume. In case of liquid, since the intermolecular force of attraction is much lower as compared to solid, so it has only definite volume. It does not have a definite shape. And gaseous, due to a negligible force of attraction between the atoms or molecules, it neither has a definite shape nor it has a definite volume. Now the interesting thing is that we can convert them into one another. Means we can convert solid into liquid and we can even convert liquid into gaseous. So let us see how we can convert the solid into liquid and liquid into gaseous. For example, so many times we have done this. So many times we have convert water. Suppose we take a water and when we keep it in fridge, we keep it in deep fridge, it become what? It become solid. So see, the liquid water, we are converting here a liquid into solid. And again, if you just take this ice cube out of the refrigerator and keep it in some place, this will again get converted into what? Liquid. So see, we can convert different states of matter one into another and they are reversible. Means we can convert solid into liquid and again we can convert back. That's why here reversible. This sign is known as a reversible sign. Means we can convert solid into liquid and again we can convert liquid into solid. This thing is true for gases also. We can convert liquid into gaseous and liquid gets back to liquid. And the gaseous once again get back to liquid state, right? That's why rain occurs and all other phenomena is there. Now this name we have to know. I think we already know, but still let us see once again. What is the name? When we convert solid into liquid, this process is known as melting. So what is melting? Melting is a process by which solids gets converted into liquid. And what is boiling? Boiling is a process by which I want to mention something. There is a difference between boiling and evaporation. There is a difference between boiling and evaporation. We will discuss evaporation and then we will see what is the difference between boiling and evaporation. They are not same. So liquid on boiling get converted into gases. And when gases come back to the liquid state, we call the process as condensation. And when liquid comes back to the solid state, we call this as a freezing point. We call it as a freezing. Okay. Now there are some cases where solid directly gets converted into gaseous state without getting converted into liquid state. And this is an example. So this is an example. Here this is solid iodine, and when we heat the solid iodine, it directly gets converted into vapor. You see, it is directly getting converted into vapor. So whenever we are heating the solid iodine, it is getting converted into what? It is getting converted into vapor. It is getting converted into vapor. So the changing of a solid directly into vapor, this process is known as sublimation. So what is sublimation? Sublimation is a process by which we can convert solid directly into liquid. Now, come to our next topic. Effect of temperature and pressure on the interconversion of change of matter. See, solid, it getting converted into liquid. Upon what? How does solid get converted into liquid? When we apply heat, and this is the symbol of heat. In higher classes, we will use this symbol oftenly, but for now, just remember this is a symbol of heat. And liquid upon heating, getting converted into what? Gases. So why why the solid get converted into liquid and liquid gets converted into gases upon heating. What happens actually? See, when we heat a solid, its kinetic energy increases. When we heat a solid, its kinetic energy increases. And what is kinetic energy? Kinetic energy is half mv square. Kinetic energy is half mv square, where m is the mass of the particle, v is the velocity of the particle. See, so since the kinetic energy is increasing, that means what? When we are heating, the velocity is increasing. The velocity is increasing. So what will happen? You see, when we are heating, right, the kinetic energy is increasing. Kinetic energy is increasing means the velocity is increasing. So they will now not like to stay like this. Since the velocity is increasing, so the intermolecular force of attraction between them will tries to decrease. Since the intermolecular force of attraction between the molecules will decrease, they will be getting converted into liquid, and on further increase they will be getting converted into gases. This is the case with temperature. Now what will happen with pressure? What will happen with the pressure? There is a famous law again which you will learn in the higher classes, but it is not in your course now, but still I am just mentioning a name here. There was a famous scientist, whose name is Henry. There was a famous scientist whose name is Henry. Henry first actually observed that the solubility increases with increase in pressure. See, and actually with increase in pressure, with increase in whatever the phenomenon we are seeing, when we increase the pressure, what happens? When we increase the pressure, what happens? See, come to the main diagram. When we are increasing the pressure, that means what? They will be coming closer to one another. Since they will be coming closer to one another, so the intermolecular force of attraction will be increasing. And that's why when we increase the pressure, the gas get converted into liquid, and on further increasing pressure, it gets converted into solid. So when we increase the pressure, the gas gets converted into liquid, and this is actually very widely used in the different fields. For example, the cold drinks that we drink, it has a gas called CO2 dissolved in it. By applying the Henry's law, CO2 dissolved in it. By applying high pressure here, CO2 is a gas which is converted into liquid. And whenever we open the container, what happens? The pressure is decreased. Once again, the liquid gets converted into gases. Okay. So see, on increasing temperature, the solid becomes liquid and liquid becomes gaseous. While it will exactly reverse with pressure. On increasing pressure, gases gets converted into liquid and liquid gets converted into solid. Okay. Now, a very interesting topic, evaporation. Here we will discuss. Okay, now before going to evaporation, I have to discuss something which I told earlier that I will discuss later. So now here you see the force of attraction between the molecules is highest in case of what? Is highest in case of solid. The molecules are what? The molecules are most closely packed in solid, then in liquid, and then in gases. That is why, while discussing the properties of the solid, we say that solid have a high density. High density means mass per volume is highest in solid, because the molecules are closely packed in case of solid. But now come in case of liquid. This is not the case. In case of liquid, since the molecules are not that much closely packed, so it does not have such high density, but it is much higher as compared to gases. Now come and let us discuss about evaporation. So, what is evaporation? See, there is a little difference between evaporation and boiling. First, let me tell you that evaporation is a natural phenomenon. Evaporation is a natural phenomenon that occurs at any temperature. Whereas boiling occurs, suppose we take a beaker and inside the beaker we have an H2O molecules. We have our water, right? We have taken H2O and we have H2O, correct? And we are supplying a constant heat in it. So what will happen in case of boiling? The molecules will be in a constant random motion. The molecules will be in a constant. The molecules will be in a constant random motion. And since the molecules are in a constant random motion, all the molecules have almost the same kind of kinetic energy. And their boiling point is the point when their pressure becomes equal to 1 atmospheric pressure. When they receive sufficient amount of heat, when their pressure becomes equal to 1 atmospheric pressure, the boiling occurs, and we said that the boiling point is obtained. In boiling point, you remember the constant heat is given. So all the molecules of the water will have the same kind of energy associated with them, and they will then escape back into the atmosphere, and there is no cooling, because if some molecules come back, they will again get the same amount of heat and they will escape. But in case of evaporation, see in river or in pond, what happens? Some of the molecules have greater kinetic energy than the other molecules, and these are the molecules which get out in the gaseous phase, and again there is a phenomenon called cooling effect, so they again come back. In case of evaporation, all the molecules are not having the similar kind of energy because we are not supplying a constant amount of heat here. So this is a evaporation. Right, here basically the surface molecules are only involved. The molecules present in the surface generally they are generally getting the higher kinetic energy and they are getting evaporated. But the molecules present in the bulk are not getting that much of energy. But in case of boiling, the molecules in the surface and the molecules of the bulk all are having a similar kind of energy due to the constant amount of heat that we are supplying. So this is evaporation. And what are the factors that will depend on it? Of course, the surface area. Because since in evaporation only the surface molecules are involved, so greater the surface area, greater will be evaporation. And of course, with increase in temperature and with humidity, the evaporation will increase. So thank you. Let us go back to our mind map once again before concluding the class. So say we have seen today what the solid has the highest intermolecular force of attraction, and liquid has a intermolecular force of attraction in between the solid and gases have a least intermolecular force of attractions. And all these solid can be converted into liquid and liquid can be converted into gases and vice versa. Means gases can also be converted into liquid and liquid can also be converted into solid. We have learned a special method which is known as evaporation, by which liquid gets converted into gases. So in our next class we will be learning about latent heat. Right, and we will be learning about temperature conversion, how we can convert different scales of temperatures, one unit into another. And in the upcoming videos we will solve our NCERT question and answer. So the note of this class will be given to you in the PDF format. So that's all. Take care, stay at home and stay safe. Thank you so much. We will be meeting next on Friday.